Hello, my dear students. How are you? I'm very happy to connect with you this another time. My name is Naftal Lucas, and I'm teaching chemistry. Today, I'm going to present to you a very nice presentation from the topic of amine, and the subtopic is preparation, properties, and uses of amines. But specifically, the presentation of today will be based on the chemical properties of amine. Preparation, properties, and uses of amines. Now, students, this presentation is very important. Why? Because it contains some of the questions or problems which needs explanation. Sometimes you can be asked to explain with the aid of chemical equation, or you can be told account for the following observations. So these questions which are coming in this way, most of the students are getting challenges. So today's presentation will give you the knowledge on how to solve these problems. So I'm sure that by the end of today's lesson, you'll be able to apply the chemistry knowledge in solving day-to-day life challenges. So I warmly welcome you to connect with me till the end of this lesson, and I am sure that you're going to be competent and comfortable in solving different problems. Now, as I said that I'm going to focus more on the chemical properties of amines, but I cannot go directly with you to that particular part. First of all, it is important to to know what is all about amine. I hope that you have studied this in the class. So let us share the ideas together. What is it all about? From there, we can go on with our presentation about the chemical properties of amine. So we start with what is all about amine. If I ask you the question, my student, what is amine? What are you going to say? Right there you are. What are you going to say? Amine, these are organic compounds which are formed when at least one hydrogen atoms from ammonia is replaced by alkyl group or by allyl group. That is all about amine. So yes. So this is the definitions of amines. At least one hydrogen atom is replaced from ammonia by alkyl group or by allyl group. And I'm sure that when we talk about alkyl group, you know what is it. Alkyl group. Alkyl groups, these are coming from alkane, and they are formed when one hydrogen atom is replaced, is removed from it. And when we talk about allyl group, these are molecules containing the benzene ring. So this is all about amine. Now, from there, where we can have some examples on the amines. number 1. Look at this one. We have this one alkyl group. This is methyl group. Has replaced one of the nitrogen atom from ammonia. Look at the second one. This is another group. This is allyl group. It is called phenyl group. Has replaced one of the hydrogen atom from it, from nitrogen. And this is also another example of amine. There are 2 allyl groups that have replaced 2 hydrogen atoms from nitrogen, from nitrogen of ammonia. So you can see here. Just take these examples seriously, because at the end we are going to get the classes of amines from these particular examples. We have another one. Just look at that one. This is alkyl group. These are alkyl groups. And this is allyl group. So you can see there is no hydrogen atom or nitrogen. That means all the hydrogen atoms have been replaced from nitrogen. So these are examples of amine. From these examples, we can get the classes of amine, because it is not, it won't give us a good idea of discussing about the chemical properties of amine if we don't know the classes of amine, because in some extent each class reacts differently. So let us see the classes of amine. Now, using these examples, if I tell you to classify these ones into the classes, what are you going to do? Let us look at the 3 classes of amine. The first one is called primary amine. So it can be written this way. The second one, we have secondary amine. Can it be written this way? And the last class that we're going to discuss is tertiary amine. These are the classes that you're going to consider today. Though there is another one that is quaternary amine, anyway, that we're not going to discuss it today. We're going to look at these 3 classes, which are very common. Now let us look one after another, starting with the first one. Primary amine. What is it all about? If I write the examples here, just like the examples I gave in the introductory part, are you going to can you be able to define what are they about? Primary amines. Examples here. That is example 1. This is example 2. Now, if I tell you to define what is all about primary amines using these examples, what are you going to say? You can see nitrogen atom is bonded only to 2 hydrogen atoms. So that means we have the alkyl group here has replaced 1 hydrogen atoms from ammonia. That means they have remained 2. And this allyl group also has replaced 1 of the hydrogen atom. So we can simply say primary amines, these ones are formed when 1 hydrogen atom from ammonia is replaced by either allyl group or alkyl group. So here, nitrogen atom is bonded to 2 hydrogen atoms. As you can see. So this is primary amine. Now from here, we can also see what is all about secondary amine. Now, secondary amine also, if I give the examples here, and from these examples, I want you to tell me the definition of amines, secondary amines. Yes, these are the 3 examples of secondary amine. From these 3 examples, can you tell me what are secondary amines all about? Now, from here, you can see there is 1 methyl group and another methyl. So 2 methyl groups are present on nitrogen atom. There is only 1 hydrogen atom. And here we have allyl group. We have another alkyl group. There is only 1 nitrogen, only 1 hydrogen atom. For this case also, we have 2 allyl groups. These are 2 allyl groups, phenyl groups, bonded to nitrogen atom. There is only 1 hydrogen atom. So from here, we can say that secondary amines, nitrogen atom is only bonded to only 1 hydrogen atom. Yes. So that means the 2 hydrogen atoms have been replaced by either 2 alkyl groups or 1 allyl group and another alkyl group or 2 allyl groups. This is all about the secondary amines. Now, after we have seen the examples of secondary amines and what are they all about, we can go to the last class that we are going to discuss today, and this is tertiary amine. Tertiary amines. Now, also I'm going to give you the examples here, and you can tell me right where you are, what are tertiary amines all about? Just consider these two examples. Just look at this nitrogen atom is bonded to, for example, for the first example, to 3 alkyl group. The first one, the second one, the third one. Can you see hydrogen atom there? No, there is no hydrogen atom. Also for this case, one alkyl group, another one, and we have the allyl group. There is no hydrogen atom. So we can say in a general way that for the tertiary amines, there is no hydrogen atom bonded to a nitrogen atom. That means all of the hydrogen atoms have been replaced from nitrogen atom. So here we can generally say tertiary amine can be written in that way. So these are the classes of amine that we have seen. Now from here, we can also discuss about the reactions of these amines. But before we go to the reactions of these amines, we have to see how reactive are amines. Because if we don't know how reactive are amines, it will be very difficult for us to proceed with the chemical reactions of amines. So we want to know how amines react. Amines always react by donating electrons, because the lone pair of electron which is present on nitrogen atoms explains how reactive amines are. So let us see the reactivity of amines during organic reaction. Now let us consider how amines react. Amines react, as I said, by donating electrons. So that means the availability of that lone pair which is present on nitrogen atoms for donation explains the reactivity of these amines. And now if that is the case, therefore we can generally say that amines are reacting as bases. They are Lewis bases. Lewis bases, these are reactive by donating a pair of electrons. So that means they react by donating a pair of electrons, and when they donate a pair of electrons to Lewis acid, welcoming the Lewis acid to come and bond to the nitrogen atom. So the electron density on nitrogen atom explains how reactive the amines can be. Now to explain that one, I hope in the class you studied about the factors affecting organic reactions. We have this factor which is called inductive effect. From that inductive effect, we can also see the positive inductive effect. Now the positive inductive effect increases the reactivity of the lone pair of electrons. How? By strong repulsion, by repulsion, because the lone pair of electrons, they are there. They need to be donated. The alkyl groups, they supply partial electron to they do what is called partial supply of electron to the nitrogen atom. So that one, partial release of electrons nitrogen atoms contain the lone pair. There is a strong repulsion there. That makes that lone pair to be donated during organic reaction, and in fact that automatically increases the basic strength of amine. Therefore positive inductive effect increases the basic strength of amine. Now looking at the three classes, here I said Now, if this is the case, that positive inductive effect increase the basic strength of amine, we can see how the basic strength of amine for each class differ. For the classes, how are they differ from each other? Here we have the primary amine, secondary amine, and the tertiary amine. Now, our expectation has a positive inductive effect is this one. We are expecting the primary amine to be the weakest base, followed by secondary amine, then tertiary amine is expected to be the strongest base. Why? Because tertiary amines here, there are 3 alkyl groups. So the tertiary amine experiences the strongest positive inductive effect from 3 different alkyl groups. So we are expecting this one to be the strongest base. Secondary amine, this one receives positive inductive from 2 alkyl groups, and the primary amine from only 1 alkyl group. So this is our expectation, that increase of these classes. But is it true? Let us see. Because we have said that tertiary amine experiences the strongest positive inductive effect, in that way makes them to be the strongest bases. But in fact, there is another factor that we have to look at. This factor is steric hindrance. Tertiary amine experiences steric hindrance. Now, for the Lewis acid to the nitrogen atom, because the nitrogen atom is overcrowded by the 3 alkyl groups. Therefore, if that is the case, we are expecting that the tertiary amine to be the weakest base. There is something that we have to note there. Explaining the basic strength of amine as per positive inductive effect, this is our expectation. But another factor which limits this expectation is about the steric hindrance. If that is the case, we are going to have another arrangement which is the proper one, because you have to balance the 2 factors. Now, the proper arrangement, we are expecting that the tertiary amine to be the weakest base of all because of the steric hindrance of the nitrogen atom to the Lewis acid, because it experiences steric hindrance from 3 different alkyl groups. Now, secondary amine, this one is the strongest base of all classes, because here there are 2 alkyl groups. That means it experiences stronger positive inductive effect as compared to primary amine. Therefore, this will be the strongest base. And this primary amine will follow. So here we are going to have this one. Tertiary amine will be the weakest base of all. Why? I have said that the tertiary amine it experiences a stronger positive inductive effect, but what makes them to be the weakest base of all is that the steric hindrance from 3 different alkyl groups makes it difficult for the Lewis acid to come and bond to the nitrogen atom. Therefore, these become the weakest base, followed by primary amine. Primary amine is also receiving the positive inductive effect from only 1 alkyl group. So the strongest one we have said is secondary amine. It receives the positive inductive effect from 2 different alkyl groups. So this is the proper arrangement. So it is important here to remember that the positive inductive effect increases the basic strength of amine by stabilizing the positive charge of nitrogen atom, which is formed by the nitrogen atom to accept the proton. Now from there, there is a partial neutralization of the positive charge by partial supply of electron by positive inductive effect. So we can see how these amines differ from each other. So we can also, sometimes you can be asked to compare the basic strength of different compounds containing nitrogen atom. Here we can have this arrangement. Different organic compounds. Yes. So this is the arrangement comparing the basic strength of different organic compounds. If I ask you, I can ask you some questions here. Now take a piece of paper and write this question. Why amide is the least, the weakest base of all? Why? What is the reason for this? And aniline. Why aniline is a weaker base as compared to ammonia, tertiary amine, primary amine, and a secondary amine? Take a piece of paper and write those questions. I will come to explain to you as we are going to see some examples on how these ones are different from each other. Now from here, my dear student, we can see some chemical reaction now, but because we have seen how different classes differ in terms of reactivity on how they donate a pair of electrons during organic reaction. We have seen primary amine, secondary amine, and tertiary amine. And we have seen that the amines react by donating a pair of electrons from nitrogen atom due to organic reaction. Now we need to justify these explanations by chemical reactions. So we can see some of the chemical reactions now. And remember that amines are basic in nature, as we have said. So if they are basic in nature, let us see the reaction of it as a base. That means the amines react with acids. Acid like hydrochloric acid, we have another one. This is nitrous acid, hydrozonium ion, nitric acid. These are the acids that we can talk about. Now, examples. One, we have this primary amine reacting with hydrochloric acid. Now what will happen? Remember I've said that the amines react by donating a pair of electrons. So there is a lone pair of electron or nitrogen atoms. So this initiates the reaction by attacking this proton. And there is a bond between hydrogen and chlorine. So this will move in that way. So here, this proton will be welcomed here. So we are going to have this one, this compound. When this proton comes here, they are going to be 3 hydrogen atoms. But this one will be positively charged because it has lost its lone pair. And we have the chloride ion there. So this one can stabilize this positive charge, so they can be together forming this one. This is called methyl ammonium chloride. Methyl ammonium chloride. That is one of the examples. We can see more examples so that you can come. Now, let's have a short break and we'll be back. Stay tuned. Now, my dear students, welcome back. Let's proceed to see some more examples of the chemical reaction that we started. We can have example 2. How about this one? This is the secondary amine. What happens for this secondary amine? Here, there is a lone pair of nitrogen atoms. And this nitric acid is that means it releases a proton. So this lone pair will attack this proton, and the electron automatically move to this. So here we are going to form this compound. These hydrogen atoms, when it comes here, that means you are going to have 2. We are going to have 2 because this one and this one, when welcomed here, there will be 2. And this nitrate group, this will be positive. This nitrate group, which is negative charge, it will stabilize this positive. So this one will react together from this compound. So you can see some examples there. But also we can have this one as well. Yes. This diethyl amine, which is a secondary amine, reacting with hydrozonium ion. Now there is a lone pair here. This hydrozonium ion is an acid. So this is the base. This is an acid. If it is an acid, that means it can donate a proton. So we can write it in a proper way, this way. This is the proton which is given, which can be given there. Therefore, this will attack this proton, and automatically we have this one. That means here we are going to have this compound. There are going to be 2 hydrogen, and here we are going to have this one. So that is the one. So this is the base. This is an acid. Here we are going to form a conjugate acid-base pair. If this is the base, when it accepts a proton, it becomes a conjugate acid. So this is the conjugate acid. And this acid, after it has lost a proton, it becomes a conjugate base. So that is a conjugate acid-base pair from that example. We can also have another example here. This is example 3, example 4. this phenylamine or aniline, it has got lone pair. So this one will attack this proton and this electron will move towards there. So here we are going to have this compound. This proton will be welcomed here to make 3 hydrogen atoms. But this will be positive charged since it has what's lone pair. And we have chloride there. So this chloride ion and this positive will make the compound, which you can write it here in this way. It will be this way. This is phenyl ammonium chloride, which is a soluble compound. Now, my dear students, from here we have seen a very important reaction. Now we can see the reaction of amines with nitrous acid. This reaction is important because here we can see how different classes react, and we can distinguish between each class of amine. Let's see the first one. Here, the primary amine react with this nitrous acid, which is sometimes written as this way, to give primary alcohol, nitrogen gas, and water, which is a liquid. Example of this one, this ethyl amine, when react with this acid, nitrous acid, the primary alcohol will have the same number of carbon atoms as the amine. So here we are going to have this one. You are going to form primary alcohol, which is ethanol, plus nitrogen gas and water. So let me write them here. This one. This is a clear solution, but this nitrogen gas which is evolved, it will come out as bubbles. So that is how you can see that this is the primary amine. It reacts with the nitrous acid, giving a primary alcohol and water as well as nitrogen gas. But this nitrogen gas will come out as bubbles from this clear solution. Now that is primary amine. How secondary amine react with the nitrous acid? We can see another one here. Nitrous acid that written that way. Here we are going to form a yellow oily liquid will be formed. N-nitrosoamine will be formed, which is a yellow oil. We can have some example to see this one. Now, here, the little mechanism here, it is very simple because there is a lone pair there. This lone pair will be donated to this proton, will be the proton, because the bond here between oxygen and nitrogen, oxygen is more electronegative, so this will be the proton. Therefore, this lone pair will be donated this proton, and we are going to form the following. This nitrogen atom will be positively charged because it has lost its lone pair. And we are going to have this hydroxide ion. So to stabilize this positive charge on nitrogen atom, this bond between nitrogen and hydrogen will break heterolytically. This is a yellow oil. So it will be observed as oil. So you can distinguish between the primary amine and the secondary amine in this way. It is very simple to distinguish that one. But for the case of tertiary amine, there will be no observable changes because there is no replaceable hydrogen atoms from nitrogen. So a clear solution will be formed. In that way, there will be no observable changes. So from there, I can ask you the question, my student, how can you distinguish between the three classes? Because these questions are coming. Distinguish between primary amine and secondary amine, or secondary amine and tertiary amine. So it is important for you to consider these ways of explanation. So we have explained about the chemical reactions of amines as bases. Now, let us see some examples. Let's see some examples. Now, my dear student, we have some examples here to see how the questions are coming. How the questions are coming. Now, let's look at this example. Account for the following. Number one, this is A. Ammonia is a strong base than water. How can you account for that one? We have seen how the basic strength of different compounds can be compared. We have seen that one. How can you explain that one? Now, this one is very simple to explain. Ammonia is a strong base than water. If we come back to the board here, trying to solve that problem, this ammonia and we have water. This is a strong base compared to water. Why? If you remember, I told you that the basic strength of any chemical substance depends on two things. Number one, it depends on the availability of the lone pair of electron to be donated. But also, it depends on the electron donating atom containing the lone pair in that particular compound. So if you look here, nitrogen atom is less electronegative as compared to oxygen atom. Therefore, nitrogen atom is more electron donating atom. This reason makes ammonia to be the stronger base as compared to water. That is a very good reason to explain for that particular part. Coming to the second question here. The second question says, aniline is a weaker base than ammonia. If you meet with that question, how can you be able to solve that problem? Remember, I told you that the question coming from this particular part, sometimes they need you to explain with the aid of chemical questions. These are competence-based questions. Now, let us see what is all about that one. For the second, this was A. B. Yes, aniline is a weaker base. Aniline is this one, phenylamine is a weaker base than ammonia. How? Now, for the case of aniline, the lone pair on nitrogen atom are not available for donation during organic reaction because this lone pair is involved in mesomerism in the benzene ring. Therefore, they are not available. This makes the aniline to be a weaker base than ammonia. But for the case of ammonia, the lone pair nitrogen atom is readily available for donation to the Lewis acid. So we can see here, if you want to compare that one, there is a lone pair there. We can see some resonance here. This lone pair can be donated to the benzene ring. That's why it is not available for the for donation. And when it comes here, it moves this way. So, and that is mesomerism in amine. So there we are going to form this one. When this loses a proton to this benzene, it becomes positive, here negative. So the bond will be formed there between the carbon and that one. So this carbon, the electrons move to here, this will be negative. And we have that one. From there, my dear student, this electron will move to this carbon and also moving here. This electron comes to this carbon. From here, it moves this way. So here, we are going to have this one. But remember, this is still positive because it has lost its lone pair. That means the lone pair have been involved in mesomerism. So this, when it moves from here to here, here it will become positive, here negative, it will form a double bond here. And this will be negative, and there is a bond there. So this electron also moves to this carbon, and from there it moves that way. From there, we are going to form the following. Let it me write it that way, here, down. So when it moves here, it will become positive or negative, a bond will be formed there. And this one will be negative because the electron will come here. And here, nitrogen, so let me write it properly here. Remember, this is positively charged. This one. Yes. From here, it can come back here and come back here as well. So it will return it to its normal. So you can see there. So that's why we say that in aniline, the lone pair are not available because they're involved in mesomerism. So that is very simple to explain, my dear students. How about this one? You can also explain this one. Take a piece of paper and write yourself. Dimethylamine is a stronger base than aniline. It is very simple to explain this one because I have told you how these compounds differ in terms of the basic strength. I have explained it there. Aniline is soluble in aqueous hydrochloric acid. I have explained it on the body here. So you can take a piece of paper and try to solve these problems. So my dear student, it is very important when it comes to the questions, wanting you to explain with the head of chemical questions, this particular presentation, I am sure that it has helped you to gain the knowledge that can help you to solve different problems. These amines, they are very important in our daily life. So we can see some more examples and different calculations and different equation in the coming presentation. So hope to meet you in the coming presentation. But it is important for you to remember the following things. Number one, you have to remember how each class how the class of amine differ from each other in terms of basic strength. It is also important to compare the basic strength of amines from other organic compounds. It is important. I have given you the concept. It is also important to remember how to distinguish chemically between each class of amine. It is important for you to remember that one. So I welcome you for the second lesson that we are going to deal more on the chemical properties of amine. Thank you very much. Have a good time. Bye.